Hello students. So students, today we are going to start chapter Gravitation. Gravitation is a very important chapter not only for class 11th syllabus but also for class 12th, because there are many concepts and formulae in this chapter which are very useful for class 12th chapter 1 and 2 also. So this is a very important chapter for JEE and NEET also. At least one question comes every year from gravitation in JEE and NEET papers. Like in 2021, in 2022, 2020, there was one question in each of those papers in JEE exam and 1 to 2 questions in NEET also. So there are many important concepts. If we talk about the school exams, there are many important concepts, definitions, derivations and numericals in this chapter which are frequently asked in unit tests, in half yearly exams and in final exams also. So let's start. First topic we are going to discuss today, which is Newton's law of gravitation. We are going to discuss this topic in very much detail, and there are 2-3 very important numericals based on this topic which we are going to discuss after discussing the concept, right? So let's start. So what is gravitation? You all must have heard the story of Newton, who was sitting under a tree and an apple fell on his head, and he then started thinking, why did the apple fall on ground only? Why it did not go towards the sky? So he then made the concept of gravitation. So what is gravitation? So gravitation is a force with which any two objects of this universe attract each other. Like you can see many objects around you, any two objects, pick any two objects, and those two objects are attracting each other with a force which is called gravitation, right? Like this is a stylus, and this stylus is attracting me and I am attracting this stylus with a force which is gravitation. But gravitation is a very weak force which we are going to study shortly. Gravitation is a very weak force, so you cannot see the attraction. Like this stylus is attracting me and I am attracting this stylus, but we are not going towards each other, right? That doesn't mean that force does not exist between these two bodies, but this force is very weak. Now, formula of this force is given by Newton's law of gravitation. Newton's law of gravitation says, like, there are two bodies M1 and M2. So Newton's law of gravitation says that the force of attraction, force of gravitation between these two bodies depend on what? It depends upon the masses of these two bodies and distance between the centers of these two bodies, right? You must have studied this law in class 9th also, so that is the same law, but don't worry if you don't remember that concept. I'll teach in detail. So what does it say? It says that any two bodies of this universe attract each other with a force which is directly proportional to the product of masses of the bodies and inversely proportional to the square of the distance between the bodies. So here we have two bodies. Mass of one body is M1, mass of second body is M2, and the distance between their centers is R. So force oh, red color, I don't like it. So force of attraction between these two bodies is directly proportional to the product of the masses of these two bodies, which means more the mass of the body, more is the gravitational force, right? Second, it says that this force is inversely proportional to the square of the distance between the bodies. If the distance between the bodies is what? Here the distance means the distance between the centers of the two bodies, right? From this point, which is the center of this body, to this point, which is the center of this body, right? From this point to this point, this whole distance is R. Then law says that force is inversely proportional to R square, which means that if we increase the distance, then force will decrease, and decrease according to square of the distance, right? Like if we double the distance, then force will become 1 upon 4 times, because double means square of 2 is 4. So if we double the distance, if we put 2R in place of R, then this square will apply to that 2 also, na? So that force becomes 1 by 4, right? Okay, so if we combine these two, we get a formula F proportional to m1 m2 divided by r square, or you know this, when we remove the sign of proportionality and put equal to sign, a constant must appear in the formula, and this formula is no exception. Constant g appears here, which is called universal gravitational constant. Universal gravitational constant, right? So there are some constants having word universal, right? Like universal gravitational constant and universal gas constant. But there are other constants also whose name do not have this word universal, like acceleration due to gravity. We do not call it universal acceleration due to gravity, though it is a constant. And pi, it is not universal pi. So when we use this word universal and when we do not use this word universal with the name of a constant, we are going to discuss this shortly. But right now let's focus on this thing. This g which is appearing in this formula is called universal gravitational constant, and its value is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. So how did this unit come? Students, if you know the formula, don't just mug up the unit, right? You can easily find the unit of any variable from the formula if you know the units of other variables. So when I ask this in my classes, and what is the value of g, everyone say that the value of g is this. But when we ask them what is the unit of g, so only 50% students can answer this question. But you can also answer this question. What is the problem with the rest 50% is that they think that they have forgotten the unit, but but you do not need to remember things now. If you have the formula, right, it is fr square by m1 m2, right? And you know the units of all the other quantities which are present in this formula. You know the unit of force, which is Newton. You know the unit of r, which is meter, and everyone knows the unit of mass, which is kg. So what is the unit of g? Newton meter square per kg square. So you don't need to remember many things. Just try to learn things. Do not try to just blindly remember or mug up things, right? So the unit is Newton meter square per kg square. So why we are calling it universal constant? Universal means whose value does not change in the entire universe. This is right. We have not visited each and every planet, not a single planet except ours. But entire universe means what? Entire universe in human language means that the part of universe which is being studied till now, right? We have not found any exception or any other form of this formula where we have to use any other value of this constant. This formula from atoms to galaxy clusters, stars clusters, can be easily applied, right? From such a small entity like atoms and molecules, this formula is applied, and to such a bigger entities like stars and galaxies, you can apply this formula and the constant remains always same. So that is the meaning of universal, right? So this is the formula. You all have studied this formula in class 9th, but that study was very shallow. There was not much discussion about this thing. So now we are going to discuss many important things about gravitation and many important questions also. So first we will discuss the vector form of Newton's law of gravitation. It is nothing new. It depends on your knowledge of topic vectors. If you do not know the concepts of vectors, you are always going to find physics very hard. If you know the concepts of vectors, if you know the concepts of calculus like differentiation, integration, and few mathematical formulae, then physics is going to be very easy for you. Students come to me and they say sir physics समझ में नहीं आती, because they cannot understand physics. Then I ask them, do you know vectors? They say no. Do you know calculus like integration, differentiation? They say no. So physics, you can never understand physics. So these are the basic building blocks, pillars of physics. So if you know the concept of vectors, this is nothing new for you. But if you do not know the concept of vectors, you are going to find it somewhat confusing, but there is no confusion here. What is the concept of vector says? Like we have marked it F12. F12 means the force of attraction on object 1 due to 2, and we have marked it F21, which means the force of attraction on object 2 due to 1, right? Now we are using the vector sign here. The magnitude of this force is given by Newton's law, which is this, and this force is equal on both the bodies. We will shortly study the properties of gravitational force. One of the major important properties of gravitational force is that this is a mutual force of attraction. The magnitude of force which is applied by m1 on m2 is equal and opposite to the magnitude of force which is applied on m1 by m2 or m2 by m1. Both these forces, F21 and F12, both these forces are equal and opposite. So they obey Newton's third law also, right? So what is the magnitude of this force? Suppose magnitude of this force F12, which is written by this or this. If you are just using the symbol and not putting the arrow sign, that means you are talking about the magnitude. But if you are putting the arrow sign over the head of the symbol and still you want to write it as a magnitude, then you have to put these two lines which are called modulus, right? So both these things have same meaning, and the magnitude of this force is G m1 m2 by r square. But magnitude we have already studied now. So we are talking about the vector form. So what is the vector form? What is vector? Vector form of any variable, any parameter, is the magnitude of that thing. So we are talking about the vector form of force. So what is the vector form of this force? Magnitude of force into unit vector in the direction of this force, which is taken as r12. And unit vector is shown by putting this sign over the head of the symbol. This sign is called cap or hat. This must be some direction. Let us say this is x-axis. So there must be a unit vector along this direction. So we have taken that r12. So what is vector F2? Magnitude of force F12. What is vector F12? Magnitude of force F12 into unit vector in the direction of this force, right? So what is the magnitude? Magnitude is this. Into this unit vector, or we should write and. Now we are talking about the other body. And what is this vector? F21. This vector is the magnitude of this force into unit vector in the direction of this force, which is taken as r21, right? R21. So this is G m1 m2 by r square into r21. And you know that these two unit vectors are acting along the same line but in opposite direction. So these two unit vectors are representing the same direction but in opposite way, right? This is not the same direction. This is representing this direction, this is representing this direction, but they both are the unit vectors along the same line. So if this is I cap, this is also I cap, but in minus. So this is I cap, this is minus I cap, right? So we can write, since r12 vector is a negative of r21 vector, therefore F12 is negative of F21. Because if you see this value and this value, both of these are different only in terms of unit vector, because magnitudes of both these forces are same. So we can say that F12 is equal and opposite to F21, right? So force which is applied by 1 on 2 is equal and opposite to the force which is applied by 2 on 1, right? Okay, so this was the vector form and that was the magnitude. Now we are going to discuss some important properties of gravitational force, and after that we are going to discuss some important numericals in which we are going to use this formula plus some basic concepts of vectors. So let's start with the properties first. It is the weakest force of nature. You must have studied there are 4 types of forces. In chapter 1 it was mentioned that there are 4 fundamental forces in nature: gravitational force, weak nuclear force, strong nuclear force, and electromagnetic force. Out of all these 4 forces, the weakest one is gravitation, right? This can be easily shown now, right? This body is falling towards the earth. Why it is falling towards the earth? Because earth is pulling this body. Okay, you must have heard the word gravity. So what is the difference between gravitation and gravity? The force with which earth is attracting other objects, that is called gravity. That is also gravitation, but we have named it gravity because we are living on this planet and the gravitational force of this planet is special for us. So we have given it a separate name. So gravitation of earth is called gravity. So due to gravity it is falling towards the earth. But look at the size of earth and look at my size. I am very small as compared to the size of earth, but whole earth cannot stop me from taking this body away from the earth, right? I can easily take this body away from the earth, which shows that the force with which it is getting attracted towards the earth is very weak, right? It acts along the line joining the centers of the two bodies. Gravitational force acts along what? It acts along the line joining the centers of the two bodies. This is the center of this body, this is center of this body. Now we have joined the centers of these two bodies, and gravitational force acts along the line joining the centers of these two bodies. It is always attractive in nature. We are yet to find repulsive gravity. We have not discovered repulsive gravity yet. So this is the only force which is always attractive in nature. All other forces like electromagnetic force, nuclear force, they are all repulsive and attractive both. But this force, gravitational force, is always attractive in nature. It does not depend upon the nature of medium present between the bodies. If two bodies of masses m1 and m2 kept at a distance r, and suppose you shift the arrangement from air into water as it is, keep the bodies same, keep the distance same, so there will be no change in the force. Like if two bodies are placed at a distance, at a fixed distance, in air, in water, in oil, in benzene, any other medium, in vacuum, then force between the bodies do not change, right? Force remains same, so it does not depend on the medium present between the bodies. Next, gravitational force between two bodies does not depend upon the presence or absence of a third body. If we bring, suppose if we bring a third body here, right? I have brought this body here. So gravitational force between this body and this body will change, between this body and this body will change, because this body was not here, it was somewhere else. So the distance between these two bodies and this body was something else. Now I have brought this body here. So the distance between this body and this body and this body and this body changes. So the gravitational force between these two bodies and these two bodies change, but this gravitational force between these two bodies will remain same. So the presence or absence of third body around these two bodies will not change the gravitational force between these two bodies. The mutual gravitational forces between two bodies are equal and opposite, so they form action and reaction pair, so they obey Newton's third law of motion. This we have already discussed. The law of gravitation strictly holds for point masses only. these bodies on which we are applying this law, these bodies should be point masses. Point masses means these bodies should not have any dimensions, because if they do have dimensions, we have to use the concept of integration. We divide each and body into infinite small particles and then apply gravitational force formula on those two small particles and then integrate the whole thing to get the total force. This is because gravitational force, this formula is applied to point masses only, but we will apply this formula to spherical bodies without any problem, because whole mass of a sphere is considered to be concentrated at the center. So for us, m1 is not this whole body but a point object of this mass placed at the center of this body, right? And m2 is a point mass which is placed at the center of this body, not this whole body, right? So because this concept is applied to point masses only. Okay, so these were some important properties of gravitational force. Now we are going to discuss some questions which are frequently asked in school exams. So let's start with the first question, which is very easy, but just for the warm up, so we get to know that how to use this formula, how to do calculations and all those things. Calculate force of gravitation between two objects of masses 1 kg and 2 kg. Mass of one body is 1 kg and mass of the second body is 2 kg. And distance between the centers is 100 centimeter. So let's take everything in SI units. So to convert centimeter into meter, we have to divide it by 100. So 100 centimeter, which means the distance between the bodies is 1 meter. So or divide by 100, or we can multiply it with 10 raised to power minus 2. So this gives 1 meter. Now let's apply the formula. Force is G. Value of G is 6.67 into 10 raised to power minus 11 into M1. M1 is 1 kg into M2, which is 2 kg, divided by R square this. And this answer now comes out in Newton, because everything is now in standard unit, so answer will also come in standard unit, and the standard unit of force is Newton, right? So F is 6.62 into 2. That's all. 1 square is 1 and this is also 1. So 6.62 into 2, 14, 1, 12, 13, 1, 3, 3, 4. So it is 13.34 into 10 raised to power minus 11 Newton. So it was very easy, right? It was just for your warm up, so you get familiar with the formula and all other things. Now, okay, this is an important question. Next. So there are three bodies, each of mass m, which are placed at the vertices of an equilateral triangle of side A. Find the net gravitational force acting on any one of these. Now you will get these types of questions where bodies are more than two. What we have studied in formula, that formula is applied to only two bodies. But what we are going to do when the number of bodies are more than two, you will get a configuration like this, that three particles are placed on the vertices of a triangle, or you can get a configuration in the form of square also, rectangle also, that four particles are placed on the vertices of a rectangle or on the vertices of a square. So how to handle these questions? So in these questions we are going to use the superposition principle of forces. But what's that? Let's not make things complicated. You know, when there are two vectors, right? You have studied this formula in chapter vectors. So there are two vectors A and B, and the angle between A and B is theta. So the resultant of these two vectors according to parallelogram law is the diagonal of this parallelogram, which is formed by these two vectors A and B as two adjacent sides of the parallelogram. This is one side, this is the other side, then complete the parallelogram, and this diagonal is the resultant of these two vectors whose magnitude is under root a square plus b square plus 2ab cos theta, right? So this is the formula that we are going to use. You can note down this formula in your notebooks, and I'm going to rub this off. So okay, so we have to find the gravitational force on any one of these bodies due to the other two. Because there is a symmetry, so the resultant force on this body will be equal to the resultant force on this body and resultant force on this body. So let's find this resultant force on one of these bodies by using this formula and the law of superposition of forces. Okay, so let's focus on this body. Now take, if you are focusing on this body, now take other bodies one by one, right? Just forget this body, focus on this body, and think that this body is going to apply force on this body which is under consideration in which direction. So this body will attract this body towards itself. So force on let's mark these bodies. Let's say this is body 1, this is body 2, and this is body 3. So force on 1 due to 3 will be in which direction? In this direction, right? Because this body is going to attract, 3 is going to attract 1 towards itself, because gravitational force is an attractive force. If you forget this body, just imagine that this body is placed here. So what will happen on this body in presence of 3? It will try to move towards 3, na? Because gravitational force is an attractive force, right? So let's call this force as F1. Let's call this force as F1. Now find the magnitude of F1. Find the magnitude of F1. Magnitude of F1 is G, mass of one body into mass of other body. Both masses are m, so m into m is m square divided by the distance between the bodies, which is what? This distance is a, which is the side of this triangle, right? It is an equilateral triangle, so length of each side is a, so divided by a square. So this is F1. Now let's talk about F2. For F2, we will forget this body and focus on this. So what is the direction of force applied on 1 by 2? So 2 will also attract 1 because this is also gravitational force. So direction of force on this is in this direction, and let's call this force as F2. So what is the magnitude of F2? Now find the magnitude of F2. What is the magnitude of F2? Magnitude of F2 is G m into m, which is m square divided by the square of the distance, which is a. So we can clearly see that magnitude of F1 is equal to the magnitude of F2. Now what will happen if these two forces simultaneously act on body 1? This body is going to move towards this direction, and it is going to move at the same time in this direction also. So where will it go? That's why we have parallelogram law, resultant of vectors. So let's complete this parallelogram and find the resultant. So this body is going to move in the resultant direction of these two forces, which is this, right? And let's call this resultant force as F. So what is the magnitude of F according to parallelogram law? Magnitude of F is under root F1 square plus F2 square plus 2 F1 F2 into cos of angle between F1 and F2, which is 60 degree, because this is an equilateral triangle and each angle of equilateral triangle is what? It is 60 degree. So cos 60. And since the magnitude of F1 and F2 magnitudes are equal, so let's call F2 as F1. So this is F1 square plus F1 square plus 2 F1 into F1, it is again F1 square into cos 60, which is 1 by 2. So let's cancel 2 with 2, F1 square plus F1 square plus F1 square. So F is under root 3 times F1 square, which is under root 3 F1. So net force is under root 3 F1, and since we know the magnitude of F1, so the resultant force F is under root 3 F1, that is gm square by a square. So the magnitude of resultant force on this body is under root 3 gm square by a square. And what is the direction? Since these two forces are equal, and in case of equal vectors, this resultant is exactly in the middle. So this angle must be 60 degree. So we can write the resultant force acting on M is this, and towards the direction which is making an angle 60 degree with either F1 or F2. Right? So you can apply, so this is called the principle of superposition of forces, where we will find the net force on one body as the vector sum or resultant of the forces applied by this body by all the other bodies which are present around it. Right? So you can have 4 particles, you can have 5 particles, but concept remains same. Okay. Let's discuss one more question. Two bodies of masses 9 kg and 16 kg are placed such that the distance between their centers is 10 meter. Two bodies, one body, let's make a beautiful diagram first. Diagrams are very important in physics. If you write answers, then make as many diagrams as possible to explain that answer. Or if you are teaching physics, try to make some very good explanatory, beautiful diagrams that will help your listener or your student to understand the concepts better. So diagrams are very important. So these two bodies, one is of mass of one body is 9 kg and mass of the other body is 16 kg, and the distance between the centers of these two bodies is 10 meter. Where should a third body of mass 2 kg be placed on the line joining the centers of these two bodies such that the net force on the third body is 0? Now, where should a third body be placed on the line joining these two bodies such that the force on the third body is 0? What is it? What the question is asking? Let's analyze. Okay. Let's say we have a body of mass 2 kg and we have kept it in the middle. So the distance of this body whose mass is 2 kg, the distance of this body is 5 meter from 9 kg body and 5 meter from 16 kg body. But the force between this and this will be more because mass of this body is more as compared to mass of this body. So this force is less and this force is more. Both these bodies will try to attract this body towards themselves, but this force will be smaller and this force will have a large magnitude as compared to this force. Right? So this body will move towards this direction, and so the net force is not 0. No? Net force is, suppose this force is F1, this is F2, so net force is F1 minus F2. So this body will move towards the body of 16 kg mass. But we have to find a point where the net force on this body is 0, which is obviously not the middle point. Suppose this 9 kg body also had a mass of 16 kg. Then that point at which the resultant force on this body is 0 is the middle point, because in that case both these forces will have equal magnitude and they cancel out each other. But in this case, this is not the point. So how can we find the point? So let's say, okay, where should that point lie? That point should lie in this half or in this half. That point should lie where the resultant force on 2 kg body is 0. That point should lie near 9 kg body, because mass of this body is less than that body. So its force is weaker as compared to the force of that body on 2 kg body. So to make forces of equal magnitude, we have to reduce the distance between these two bodies. So at this point somewhere, suppose at a distance x, distance are taken from the center. So let's not make any mistake. Let this distance be x, which is the distance between the centers of these two bodies. Then what is this distance? This distance is 10 minus x, and we have to find the value of this x. So now it is placed at this position such that the force of attraction of 9 kg mass on this and force of attraction of 16 kg mass on this, both these forces are equal in magnitude. So let's put them equal. What is the force between these two bodies? According to Newton's law of gravitation, G into 9 into 2, G m1 m2 by r square. R means distance, which is x here, and G, what is the force between these two bodies? G 2 into 16 into divided by 10 minus x square. Okay, so we are left with this thing, 9 divided by x square equal to 16 divided by 10 minus x square. You can expand this also and then cross multiply, and a quadratic equation will be formed, and using that quadratic equation you can find the value of x. That is a long procedure, but here we can do one thing. Generally in such questions, these two bodies have masses, like if we put them in this formula, they are the perfect squares of some numbers. So instead of opening this, expanding this bracket, we will do the square root of both sides. So let's take square root of both sides. So square root of 9 is 3 and square root of x square is x. Square root of 16 is 4 and square root of 10 minus x square is this. Now let's cross multiply. 30 minus 3x equal to 4x, which gives 30 equal to 7x, which gives x equal to 30 by 7 meter, which gives x equal to 4.3, approximately 4.3 meter. So this point where the resultant force on 2 kg mass is 0, this point is at a distance of 4.3 meter from 9 kg body, and 10 minus 4.3, which is 5.7 meter from 16 kg body. So this was the concept of Newton's law of gravitation and a few of very important questions. So I'll meet you in the next lecture with the next topic, which is acceleration due to gravity, and we will do that topic in detail and many other important questions. So I'll meet you in next lecture. All the best.